about the word measure before. Can anybody tell me what, anybody talk about the word measure? Say something about the word measure. Anybody? Measure. Anybody just say something about the word measure?
It often has a number associated with it.
Right, exactly. Whenever you hear the word measure, think of a number. Okay? Everybody's analyzing, let's say, a tree. That tree tall. Someone say, well, no, that tree not tall, that tree medium, that tree is a normal tree. You have tall and you have normal, you have medium, you have short. These words are subjective words. When you have subjectivity, you have different perspective, different opinions, and you have debate and it slows down progress. Okay, this is good, but it slows down analysis. So here comes mathematics. That's why from kindergarten to university is always maths and English, maths and French, maths and Spanish. These are the two important languages, quantity and quality. Measure, you're talking about tall, short, these are qualitative analysis. A number will give you objective, quantitative analysis. And to do that, you have to measure. It appears that there might be a relationship between those two variables. You sure? You sure that variable affecting the other? Is it strong? Is it weak? Your hours of study, does it affect your score? Some might say, I study for that amount and I get that, I still get that percentage. I study for that amount and I get that. So there's a debate. But that relationship now can be measured and you're going to get a number, okay? And that number can be measured using different statistical instruments. Okay, you want to measure the temperature, use a thermometer. But if you want to measure correlation, there are different statistical instruments. You have Spearman's, you have Pearson's, but you have others. You have Kendall, you have others. You can look it up. Okay, but for this course we are using Spearman's and Pearson's. So how can we measure the correlation to get a number between two variables using Spearman and Pearson's? We did that and I sent the video on that, and here it is. In that example, 0.984 was obtained. So if you want to compare this with Spearman, you can see Pearson's is more complicated. Pearson's is more rigorous. Okay, it's a more rigorous analysis and it's more dependable. Okay, so that's why you may confront Pearson's in another statistical course in university. I've seen that happening every day. And also, I have some tutoring to do after, and the same topics come up. So please don't, save all your information and prepare for the higher levels. So you look all of this up in the video clips on YouTube. I sent you all the link. And now we move into part E. Use the results in part C to determine the gradient and the y-intercept of the equation of the line of best fit linear regression. That ties in nicely with the definition we just call up from Google. Correlation is a statistical measure that expresses the extent to which two variables, x and y, are linearly related. Y is equal to mx plus c. M is the gradient, c is the y-intercept. Also, I have a college algebra class and we're on that topic, coordinate geometry. M is the gradient, c is the y-intercept. And here you have it happening in statistics. Use the results in part C to determine the gradient and the y-intercept of the line of best fit linear regression. Write the equation in the form S is equal to MH plus C. So X and Y are general variables. S now is for, what do you think S stands for here? Anybody, what do you think S stands for here? Anybody have been looking at the videos? What do you think S stands for? What do you think H stands for? Number 11, part A. You have hours and score. What do you think? I was saying, what do you think H stands for in this expression there? In this question, it says, write the equation in the form S is equal to MH plus C. So I was asking, what do you think S stands for? And what do you think H stands for? Because E follows from part C. Okay? So S stands for score and H stands for hours. So there must be a relationship between hours and score. And this was calculated using Pearson's, and we also calculated it using Spearman's also, hours and score. So hours is the independent variable represented by the letter X. Score is the dependent variable represented by the letter Y. Okay? So you have Y is equal to MX plus C. Y would be general letter, X would be general letter, but here specifically X will be H. X stands for hours. I'm just using the letter H, and Y for score using the letter S. So that's why you have S here as the subject of the variable. Y is equal to MX plus C. S is equal to MH plus C. Now, to determine the gradient, we can all remember y2 minus y1 over x2 minus x1. But here now, there's a special gradient, an equation for gradient, which follows up from the equation from the Pearson's. All right, the formula for the Pearson's. All right, let me look it up, the formula for the Pearson's. Number 11 AB, number 11 C and D. AB was Spearman's, C and D, that's where we introduced Pearson's. All right, so here's the values we used. All right, hours of study, how does it affect your score?